Are you tired of seeing layer lines in your 3D prints? Then fear not, as there are a few simple methods you can use to effectively hide them, which I'll be showing you how to do in today's video. But before that, hi there, I'm Matt, and I've been 3D printing for nearly 2 years now, and designing my own models for over a year. And on this channel, I'll be showing you lots of tips and tricks for improving your 3D printing knowledge and experience. Without further ado, let's get into today's video. So you will need to be in your slicing software for this. As usual, I'm using Bamboo Studio. Before I get into the two main things I want to show you today, I just want to go through some of the more simple things you can do. The first and most obvious thing is to just change the layer height. So the smaller the layer height, the less visible the layer lines will be. Obviously. The standard layer height is 0.2 millimeters. As you can see here, this is the standard print profile that most slicers use, in particular Bamboo Studio, which for the most part is fine. Like, I print a lot of things with 0.2 millimeter layer height, and you don't get crazy visible layer lines, but depending on what material you're using, for instance, basic PLAs are quite susceptible to showing layers. So if you click on the drop down here for the user presets, you can see a bunch of system presets that exist. So for a 0.4 millimeter nozzle, you can drop the layer height down to 0.08 millimeters, which will give the least obvious layer lines, but will naturally lead to a much longer print time. So if we just directly compare it right now, so if I slice this model with 0.2 millimeter layer height, it'll take 40 minutes. Whereas if I change it to the 0.08 extra fine layer height and slice, it's now going to take an hour 5. So that is an extra 20 minutes, which might not seem like a lot, but obviously in this case it's a simple model. But depending on how complex your model is, this will increase the print time a lot. Just a side point, you don't have to change the whole print profile to decrease the layer height. You can do it here in the quality tab. Under layer height, you can set this to whatever you want. So if you wanted 0.08, you can write it there instead of changing the whole print profile. And as you can see, you can also change the initial layer height, so the layer height of the first layer. Even with the 0.08 millimeter layer height, this is still set to 0.2. Basically, if the layer height of your first layer is too small, this can lead to bad print bed adhesion. That's why the first layer is usually still kept as 0.2 or higher. So if I change the layer height back to the standard 0.2 millimeters and then slice and zoom in, you can now see these layer lines I'm talking about, particularly for a curved model like this. So you can see this like obvious stepping of the curved surface towards the top, which with a larger layer height will be more visible. So if I do the same using the 0.08 millimeter layer height, is much less obvious. Again, at the sacrifice of print time. There are some ways you can reduce this stair stepping outside of the two main methods I'm going to show you today. The first one is to locate the specific setting in the quality tab. This is under advanced here. So just a quick disclaimer, if there's any settings you can't see in your own slicer, you might have to toggle advanced settings. So here's a toggle, and if you turn it off and on, you see a bunch of new settings appear. I don't think it's one of the settings that actually needs the advanced setting turned on, but anyway. The setting we're looking for is the only one wall on top surfaces. So by default, this is turned on for top surfaces. And basically this can make the stair stepping look much worse, especially on curved models. The setting is best used for flat models, so straight edged. If you change this from top surfaces to not applied, you should see a noticeable reduction in the stair stepping. So as a quick side by side, that's what it looks like without the setting turned on. Then when you change it, it's not super obvious. It'll probably be more obvious when you print something. But this is a simple setting, especially if you've got curved surfaces. Another setting you can change, which will have a very minor effect but is good for curved surfaces, is the top layer pattern. So if you go to the Strength tab, by default, this top surface pattern is set to a monotonic line, which again is fine for most models, especially ones with flat surfaces. But if you've got curved surfaces, this can emphasize the stair stepping. So a better top surface pattern to use is concentric, because it's more a circular pattern. So if you slice this, the effect will be very minimal. You might not even be able to tell, but it will have a slight positive impact. So it's worth turning on because it doesn't affect the print in many other ways. So as I talked about, having a smaller layer height leads to less visible layer lines. However, having a small layer height for the whole model, particularly for curved surfaces, isn't necessary. And luckily there is a setting which allows you to apply different layer heights to different parts of the model. So this is called variable layer height or adaptive layer height, and in Bamboo Studio it can be found here. It's called variable layer height here. And if you click on this tab opens up, which isn't super obvious what these settings mean. This top adaptive setting is what applies different layer heights to the model itself. So if you click with the default settings, you can now see different colors appearing on the model. which means each part of the model has different layer heights. So the more red or orange parts have a larger layer height, and the green parts have a smaller layer height. And you can double check this in the bar on the side. So if you hover over it, it's saying the very top of the model has a 0.08 millimeter layer height, whereas as you go down to this part of the model, has a 0.28 millimeter layer height, which is the largest layer height you can have for this size nozzle. The smooth function here improves the transition between the different layer heights. If you click that, you can see it's basically smoothing out the changes in the layer heights. And if you press it enough times, you can get it to basically completely smooth out like that. It has got rid of the 0.28 millimeter layer height that was just visible, but it will have a much smoother transition between the layers at least, so the model won't look as bad. So if you just want the layers to look like this, you don't want any smoothing, then that's fine. I personally think you should smooth it so the bar on the side looks nice and smooth rather than jaggedy changes in layer height. And if you're thinking, doesn't this setting just increase the printing time like decreasing the global layer height does? Actually no, because it's printing higher and lower layer heights in the same model. It doesn't drastically change the print time. So if I slice this now, you can see the print time is 30 minutes 41, which as a reminder, if I reset the layer height and slice again, the print time without the variable layer height applied is 32 minutes. So in this case, it's actually reduced the print time, which is another benefit of using adaptive layer height. So if we go back onto the variable layer height setting, I didn't talk about what the adaptive slider actually does. So essentially, if you slide it further to the right, it prioritizes printing speed. And if you slide it to the left, it prioritizes printing quality. So having it closer to 1 will favor larger layer heights until essentially the top of the model. Whereas if you slide it all the way to 0, this will favor lower layer heights throughout the entire model. And as you can see, there's a lot of green on this model, which you imagine will take a lot longer to print than the first version I showed. And then likewise with the slider on the smooth setting, the higher the number for this is, the more aggressive the smoothing gets applied. So if you set it all the way to 10 and then click smooth, it basically smooths the whole thing in one go. Whereas if this was set to the default, which is 5, then you click smooth, it doesn't smooth it quite as aggressively. And also if you set it all the way to 1 and then do it, it's barely applied any smoothing. I don't really know why I would ever set it to 1, but the option is there. So if I set this all the way to 10 and smooth it, as you can see, there's a lot of green on this model, but let's see how long this will actually take to print. So this will take 38 minutes for a high quality variable layer height model, which to compare to the 0.08 millimeter preset. So if we reset this and set this print profile back to 0.08 millimeter extra fine and then slice, it's still faster than this because this will take an hour, which is double the original model's print time. I know it's not particularly clear the difference without printed examples, so I will print 3 versions of this model. One with the high quality variable layer height, so the adaptive set to 0, and then smooth it out once. And then another one with the default variable layer height settings. So the adaptive set to 0.5 and the smoothing set to 5. So click adaptive and then I'll just smooth it a few times so it looks like that. And if you slice, you can actually see the difference even without printing. So you can see the 0.2 millimeter layer height here versus the standard adaptive layer height settings here, and then the high quality adaptive layer heights here. You can see the stark difference, particularly between the 0.2 millimeter layer height and the high quality adaptive layers here. Like the stair stepping is much more apparent on the standard version. So this is the standard 0.2 millimeter layer height. You can see the obvious stair stepping here, which this is the standard adaptive layer heights added, which if you compare them is much better. And here's the high quality adaptive layers added. So you can see it's, again, a lot better than the standard one. However, not a huge difference between the two adaptive layer heights. So to save on print time, I would personally just stick to this one. It's unnecessary to use this one, I feel. The other method I want to show you is called fuzzy skin, which you may or may not have heard of. It does have a funny name. So if I delete these other 2 spheres, you're probably wondering what fuzzy skin is. So essentially the tool head will jitter randomly on the outer surface of a model, which will cause a rough texture to appear on the surface, which is why it's called fuzzy skin, so it does look kind of fuzzy. And I found this as a great way to hide layer lines and even seams for things like threaded containers. The fuzzy skin settings can be found in the Others tab. So click on Others and scroll down. It'll be under Special Mode, at least in Bamboo Studio. You can see here the fuzzy skin settings are here, these 3. So it's fuzzy skin type, and then fuzzy skin point difference, and skin thickness. So by default, it's set to None Allow Paint. I'll show you how to do that in a minute. And the other settings are Contour, Contour and Hole, All Walls, and Disabled. So Contour applies fuzzy skin to all outer walls of your model, which is the most standard way you would use fuzzy skin. Whereas Contour and Hole applies the fuzzy skin to all the outer walls and any holes you have in your model, such as magnet holes or any connector holes you've added. And then all walls, as the name suggests, applies it to all walls, inner and outer, which I don't know why you would ever use, but I'm sure there is a use for it, I just don't know. And then disabled turns off fuzzy skin completely. But if you've got it set to none allow paint and you haven't done any fuzzy skin painting, then it does the same thing. So the ones I would stick to would be the allow paint setting, contour, or contour and hole if you do want to add fuzzy skin to inner holes as well, which I believe could be good for adding friction to fittings, for example. Anyway, if I set this to contour, these are the default fuzzy skin settings. So if I then slice, you can now see the surface of the model. It looks weird. It looks fuzzy, as the name suggests. The default settings are quite aggressive, so it is a very noticeable texture on the surface, which I actually quite like, but some people might find it too textured. If that's the case, you can play with the settings. So the fuzzy skin point distance and the thickness are the two you want to play with. So the point distance, as it says here, that it's the average distance between the random points introduced on each line. And then the thickness is how wide each jitter is. And it does say it's recommended to keep this lower than the outer wall line width. I guess it's so you don't cause any weird defects with your model. You can play around with these settings and see which works best for you. The settings I found are quite nice. A 0.4mm point distance and 0.2mm thickness. But there are models on MakeWorld like this, which is basically a fuzzy skin sampler, which has a bunch of different settings on it. So you can see which ones work for you. So obviously the lower you set the point distance and thickness to, the less fuzzy it looks, and the more it will resemble a non-fuzzy skin print. I'll leave the link to the model down below if you want to print it yourself to find your favorite fuzzy skin setting. You can see the different fuzzy skin settings each time you slice. As you can see with the 0.4 and 0.2mm settings, you can see it's much less fuzzy than the default settings. If you drop this even further, so if you set the distance to 0.1 and the thickness to 0.1 as well, and then slice again, you can see there's a very fine texture on the surface now, which maybe you will want. So what are the downsides of fuzzy skin? The first one is it does increase print time, depending on what settings you're using. So if it changes back to standard settings and slice, this is going to take 37 minutes compared to around 33 minutes for the standard model. So it has added 4 minutes of print time. And if you change the settings, so if I check the 0.4 and 0.2mm settings, the print time is now 40 minutes. So it might seem counterintuitive, but the smaller the point distance and the thickness of the fuzzy skin, the longer the print time. But it does make sense when you consider that the printhead is having to jitter even more, and each of those jitters adds additional print time. So in my opinion, this is a reason not to decrease the fuzzy skin settings too much, especially if you tend to like the higher fuzzy skin settings anyway. So finally, I just want to show you the painting option with fuzzy skin. So you change this fuzzy skin mode back to none allow paint with the model highlighted. Here's the fuzzy skin painting setting, or you can use keyboard H shortcut apparently. So you press H. It'll take you to this, which is basically the same as color painting in terms of tools. So you can have fuzzy skin on different parts of your models. For instance, if you just wanted fuzzy skin there for whatever reason, you could do that. And then if I slice, you can see there's just one random patch of fuzzy skin now. I think this is particularly useful if you want to add certain parts of your model to have grip. So if you've made a cosplay prop, for example, and it's got a handle, you can selectively add fuzzy skin to that handle so the handle has increased grip. I don't think you would use this circle tool though. You'll probably use the fill tool here. So with the default filling, if I click on the model, it just adds fuzzy skin painting for the whole model, which isn't particularly useful, but you can obviously decrease the smart filling angle. And now you can see it's basically let you paint individual squares, which is interesting. So do something like that. And then what does it look like? It looks weird and stupid, but you get the idea. You can use the filling and painting tools for selectively adding fuzzy skin to different parts of your model, which can definitely be useful. I think the example Bamboo Lab give in their wiki is to add fuzzy skin selectively to a teddy bear's ears, which is cute and it makes sense. So I'll just paint the whole thing like this. One thing to bear in mind is that fuzzy skin can only apply to the Z direction, because the jittering only occurs in the toolhead Z direction. So if you've got a flat top surface, you can't add fuzzy skin to that top surface. You can only add it to the sides of a model. It's difficult to tell, but you can see this on this model. If I slice and zoom in, this top part of the model, which is like the flat, very top surface, doesn't have fuzzy skin applied. So that will just be a regular surface. So here's some fuzzy skin example prints. So here's a deck box I designed and printed. You can see the texture on the outside. So if you hate that noise, as you see, it hides the connection of the lid quite well too, but also, yeah, the layer lines, you can't really tell. And here's another one. So it's a threaded dragon egg container. And this is with a matte filament as well, so like double the bonus. And as I mentioned, it's quite good at hiding the seam of the threaded container, so the seam is there, but you can't... It's not super easy to see with the fuzzy skins. This looks really good for things like this, for aesthetic prints particularly. There is a final thing I want to say though, which is the choice of filament can also help hide layer lines. As I mentioned earlier, basic filaments such as basic PLA or PETG give more visible layer lines. However, you can use filaments with additives in them, such as matte PLA, or also reinforced filaments such as carbon fiber and glass fiber. This is a carbon fiber reinforced PLA, and you might not be able to see very well, but the layer lines are essentially invisible thanks to the carbon fiber added to the filament. It does look really good, actually. However, there is a drawback to these matte and carbon fiber reinforced filaments, which is the weaker layer bonding, which means models printed with these parts are more susceptible to breaking. So I wouldn't recommend printing with these filaments for functional or load-bearing parts, but they look great for aesthetic prints. So those were some of the simple methods you can implement to help hide layer lines in your 3D prints. If you learned something new, drop a like and a comment on this video, and while you're down there, make sure you subscribe so you don't miss any of my new videos, and I'll see you in the next one. Bye!